Okay, so last time we kind of started with MATLAB fundamentals as a very introduction, and today we're going to continue and we're actually going to work along with MATLAB. So basically, just before I start, so MATLAB is just a computing environment where you can use to write, which you can use to both execute things immediately. So I type in a command, and here comes a solution or the result of that command. Or type in longer programs that you will that will have different segments to them, and that could possibly run for longer. So of course, if you have something that is going to take 3 or 4 hours to execute, it's not very efficient to type in command by command. You know, type in a command, wait 15 minutes, type another command, wait another 15 minutes, right? So you want to actually form a program or code that you will actually give as a set of instructions to your computer to execute consecutively. So again, it's just a programming environment. There are many others. The very basics and the logic behind of it all is common to all programming environments. So the expectation is you're going to learn one, but down the line in your career, you'll have to learn others, and it shouldn't be a big deal if you already went through one structured way to program. So first things first, we need to kind of learn how to type things in MATLAB. So open up your MATLAB or click on it, double click on it, whatever it takes. You should get something like this. Okay, everybody has that? So the thing, as I introduced last time, what you see here is so-called command line, and that's the interactive part of MATLAB, where you can just simply type things, very simple things. You could just say, this is a very simple command. We're going to learn display hello. And it's going to display hello. Okay? Not very much to it. And then I would like to start typing in numerical things. And if I want to define a variable, let's say I'm going to name variable a. Okay? My a could be just a number, what I refer to as scalar. So type in, oh, hi. I trust I have Skype. I have interviewed somebody earlier this morning using Skype, and my Skype is still active, sorry about that. So A is 5, so this is my command here. Or I could actually, B could be an array, so I'm going to call B, and if it's array, I can just say 2, 3, 4. Okay? So this is a vector or an array. I have vectors are treated as matrices, so I have 1 row and 3 columns. Right? And I have number of elements in this array that is 3. If I wonder about the size, there are certain commands that are already implemented in MATLAB so that you can just use that are really useful. So size of B is one of them. It's 1, 3. So if I look at it as a matrix, it's a 1 by 3. If you look at size of A, it's 1 by 1. It's just a number. And if I wanted to make that be a matrix, so by the way, if I just type in B, this is something very useful. If I type in B and then I just press upper arrow, it's going to give me last command that started with B, and I can keep going. Okay, these are all kinds of things with B that I entered. And you can go up and down with that. So if you use up and down arrows, that's super useful, so you cut your typing. Okay? So let's say that I want to call C a matrix 2, 3, 4, and I'm going to add 1 more row, 6, 0, and minus 1. Okay? So this is now a matrix, so each Next row I basically denote by typing in a semicolon. So there are certain things, so this is basic stuff that I can just type in. I don't want to keep typing in, and we will learn how to read things in and out from files. One thing is, like, I was giving names, A, B, C. You soon run out of the ideas for names that way, okay? So you have to, in the naming structure, you have to be careful not to use too many special characters, and sometimes MATLAB will yell at you, okay? But sometimes it'll just do something. It'll do something weird without really telling you. So you want to certainly avoid special characters at the very beginning of the name. Okay? And there are certain things that are already pre-programmed. So you shouldn't be naming your command size. Size is already reserved for the name of the function. It might actually allow you to call the variable size, but then you might get like it might get confusing really soon, because in certain cases it's going to try to execute that command. Okay? And there's also certain variables, not just commands, but there's variables that are pre-stored. The one that we constantly see is this answer, ANS, okay? And that's whatever was the latest answer to the command you typed in. So that constantly changes, and it's constantly overwritten. So if you wanted to name your variable, whatever you stored would be constantly overwritten. Okay, so that's a source of error down the line. And there are certain other things like P letter that are already programmed in as well. And we can learn. We will learn those as we go. And I mentioned some of them last time. So basically, for any kind of matrices and vectors, or for any data, I can type it in, or we will actually learn certain commands that evaluate and give me outputs that I need. Okay, especially if I need to populate my reservoir model, and all I know about the reservoir is that the porosities are in certain range, but I don't know precisely where they are. Right? I don't have the measurement. Then I could actually create a random function that will kind of sample from the range of the values I need, from, for instance, 0.15 to 0.25, and so forth. So there are certain built-in functions and expressions, and also you could also import the data from files on disk, and we will all learn that. Has anybody seen Airplane movie? If not, then I'm not going to try to be funny here, because you're not going to get. But if you actually type this in YouTube, you will get the sketch from the movie that I'm referring to. So, again, as I pointed out, vectors, so go ahead now and you type in these. So type in U, type in V, so this is if I want a column vector, I will have to do semicolon after every entry to create a column vector. And here's a matrix. So type those in just to practice alone. So what's behind this quote here, the human mind has never invented a labor-saving machine equal to algebra. Algebra might not be your favorite topic, but just think about the labor you save if you have a program that is simply written in terms of, evaluate C as an A plus B. Okay? And if A and B are matrices that are 1,000 by 1,000 that you read in automatically from your file on the disk, that saves you a whole lot of typing, being able to manipulate A plus B and store the result into C without going and typing things manually on a calculator. So it's this algebra and linear algebra that are kind of tools that bridge this between doing the actual calculations and programming to make us faster. Okay? So kind of math is sitting in between. Everybody typed in this as practice? All right. So if I want to transpose a matrix, So this is what I call evaluating an expression. So just type in B is A and apostrophe, and that's going to give you a transpose of the matrix. Again, transpose translates 4, 6, 7 was a row, now it's a column. 5, 3, 2 was the second row, now it's the second column. And 1, 7, 4 was the third row, and now it's the third column. How do I think last time I stopped somewhere here in between, so I'm going to start in the middle of the class. What's your name? Campbell. So Campbell, what is the location of this element 7 in B? I2, J3. So I is 2, second row, and J, which is the column, is 3. So this is B of 2, 3. Okay? So that's important. I can get that basically by, so I had A. I'm just going to work with C. Okay? So I'm going to say B is C. I might not have a C. Okay, so C of 2, 3. Okay? Should return, in this case, -1. Right? Okay? So that's how you refer to the actual when you want to grab an actual element from that matrix. Okay? All right. So one thing that this is just the recap of what I've said so far. So can you define a variable that is A-H and call it 5? Can you try? And you all typed in A. I'm going to type it as well. I'm going to copy it. So this is my A prime. Okay. So both A and B are, what is the size or dimensions of matrices A and B? What's your name? Yeah. So what are those? 3 by 3. So can I multiply them? Yeah, because those dimensions match. Now, is A times B going to be the same as B times A? No, let's check. A times B is this, and B times A is quite obviously different. If you really strike that they're the same, that's most likely a coincidence. It's not necessarily. There's one matrix, though, that no matter, so just like number 1, okay, I multiply any number with number 1, it doesn't change. The number doesn't change. There's a matrix like that called identity matrix, and it's, we're going to get to it, but I'm going to type it in right now as I be 1, 0, 0, 0, 1, 0, and 0, 0, 1. Okay. If you type A times I is the same thing, and I times A is the same thing. And if you actually start the procedure of matrix multiplications, you can actually see why. Because if I'm multiplying with this matrix, let's say that I'm multiplying I times A, I'm going to take, for this location, I'm going to take first row, okay, and do a dot product with the first column. Okay. But I have 1 only in the first location, the others will be 0. So I'm just going to repeat that number 4 there. And you keep going like that, you will see that basically you will just leave all of the elements of A intact. Okay, so this is called identity matrix. We are going to get to there is actually a function that can give you an identity matrix of any size you'd like. Okay? And that function is called I. Okay? So try typing I of 3 or I of 4 and see what you get. you can actually go and be bold and say I of 100, it's going to be hard to verify that it's, because it's hard to print it on the screen. But you can actually, if you look at the answer here, it is 100 by 100. Okay? And it sure does have a lot of zeros. Okay? So of course, 3 by 3 matrix I can always type in myself. But if I need 100 by 100, whatever it is that I'm doing, then it's nicer to have a command that will do that for me. Okay? And then if you just want, I mentioned the random numbers. So rand command with the dimensions here will give you random numbers between 0 and 1. Okay? So if I want to scale that, I said that I want to model a reservoir with porosities between 0.15 and 0.25, so 15 to 25%. Okay. How am I going to scale this number, this output, random 3, 4, to range 0.15 to 0.25? Any of these? So I have range 0, 1, and I have a range 0.15, 0.25. Mathematically, I want a simple linear function that goes from 0, 1 to 0.15, 0.25. I'm going to find that function. I'm going to do this on the board. So I want 0, 1 to 0, 15 or 0, 25, or let's be general, to some a, b, interval a, b. I want a function f such that f of a, which is a linear function, so I'm looking for f of x that is kx plus L, for instance. That's a line, right? Or linear function. So it's ka plus L is equal to f of 0, apologies, is k times 0 is equal to a. So I want to map 0 to a, and my f of 1 has to be k times 1 plus L is equal to b. L is a, k is b minus a. So basically, b minus a times x plus a will translate my interval 0, 1 to ab, whatever a and b are. Okay. So let's do that with this rand. So let's say that I had a already. D is random 3, 4. Okay. So I want to now say, I want to translate a, okay, to 0.15 and 25. So basically b minus a is 0.1. So 0.1 times d. I can multiply the entire matrix by a scalar, right? And then plus a, which is 0.15, will give me my range of values. You can check that all of these values are indeed between 0.15 and 0.25. So just scale them. And scaling values, this is scaling, this is translation, right? Is this clear? I formalized it. This is probably something that you would intuitively kind of figure out yourself, especially if the numbers are nice. If you're scaling something between 0 and 1 to 1, 2, right? You're just going to add 1, right? But you need to stretch it or shrink it a little bit as well. And this is what this formally does. So this is one of the most useful things in creating your input, especially when you don't have particular data, but you just know the range. Being able to scale and create your self-input in reservoir simulation and geostatistics and so forth, you will find this very useful. Questions? Okie dokie. Okay. More built-in functions that we will keep using. One is some numerical mathematics, and if you remember at the beginning, one of the main things you need to do is, like, let's say you have a reservoir, you kind of have to discretize it. You have to kind of box it, okay, in the points, and you're going to be solving for function values at those points. Okay? So this get a range of points between values is a very important thing to be able to do, and linspace gives you that. Okay? So this linspace from 0, 100, 11 tells MATLAB, please give me, between 0 and 100, give me 11 equally spaced points. Okay? Here we go. Give it a try. If you want those to be equally spaced in terms of logarithms of the numbers, okay? So between 1 and 5, give me 3 points that are equally spaced. This is log 10 is 1. Log of 100,000 is 5. Okay? So these are equally spaced in log space. That could be useful too, if that's how your problem grows exponentially. And again, figuring out the size, we already did that. So give these linspace and log space a try. So linspace so if I wanted to store this result, linspace 0, 1, and 0, 100, and 11, if I wanted to store it in a variable, what would I do? Okay, so if I wanted to store this and refer to it and use it later, then I'm just gonna say v equals to, and now my vector v shows up here, it's 1 by 11. And if something is relatively small, then MATLAB will write it out for you. Otherwise, it's just gonna tell you the size. You can actually click on it to inspect. Okay? And if you click on it to inspect, you will actually see these values in the table. Or you can just say v. Okay? Table becomes a little more useful if you have a lot of data, right? So watch the workspace, or you can actually, I'm gonna click this away now. I already pointed out, this is how do I translate my subscript notation from linear algebra to MATLAB. Of course, when I'm typing programs, it's extremely hard to do subscripts. You can do that in some software that is just there for text editing, but it's hard to program that way. So the way we refer to them in MATLAB is we just say A of 2, 3, and that gives you element 2, 3 of matrix A. You can also change it up. So you can, this A, 2, 3 really accesses the location of that element on the disk and changes the value if you wanted to, or rather in the memory right now. Okay. When I say in the memory versus on the disk, what am I referring to? Temporary versus permanent storage. So temporary memory is still on the disk, but it's the working memory that is going to, if I turn off the MATLAB right now, if I close it up, all of the temporary memory is gone. So in order to save something for later, I would have to write it into a file on the disk. And then I can come in and open it up. So that's the case in all of the programs. Don't think about it twice. A lot of programs are now programmed to auto-save things for you. But normally you have to save your work. And here we will learn how to save the data as well.
I have a question.
Yes.
Changing the specific number and putting the matrix within that way, that's temporary, or is that?
It's in the memory, so it's for the time being, it's changed. So if I were to save that matrix, it would be saved with this new data. Right? So it's not going to expire after 20 minutes. I mean, it's going to stay there as long as MATLAB is open.
What's the difference between like directly editing into the workspace and the upper right corner?
I frankly rarely resort to this direct editing. This is something that keeps evolving. So I don't even know whether, let's try, let's open V. And if I change, oh, hi. If I change it to 2, okay, it's probably going to change it. Yes, it's the same. Okay. And I'll tell you why I don't resort to doing this. A, I'm old school. So back in the day when I was in school, this was not possible. But there also, the way I function often is I want to write things down because that way I'm writing programs. In programs I can save, we will call those scripts. I can save in scripts that I can come in tomorrow and re-execute. Okay? Whereas this typing in, I always have to open it up and click and type it, which is very useful. This clicking and typing is very useful when you're doing something for the first time. It enables you to test things out without being permanently recorded. But if I wanted to retrace my steps tomorrow and do exactly the same thing, I have to go open up and click again, which is tedious. And writing the program is basically, once you do that first time, you should kind of record what or your verified path or what your tested path was, so things that worked out correctly. And you save those as a program that you can, tomorrow you just come in and click on that and run. So that's the automation. So it's very important to automate things or also record what you did as a correct path because your human memory has limits, so next week you won't know. And if you need to instruct somebody else to know, then it becomes a problem. So yes, when you're testing things, you can modify things either here or here. But this is actually, so V of, what was it, third? V of 3. Now I'll change it to 4. Okay? So now it's 4, and it's actually pretty good about automatically changing it up there as well. This is a command, okay, I can save in a script and execute later. So I'm going to try to motivate you to do that and teach you the tools how to do that, because that's going to make you more effective in your work. All right. There's also column notation that saves some work. So this is, some of it is equivalent to that lin space. So if I just type 1 colon 10, it's just going to go, it's going to assume spacing is 1, and it's going to create 10 numbers in between with the spacing 1. So you can kind of work with both of those, whatever is easier for you. I can actually make them have precisely the same result. And also if you want spacing to be something else, like 2, then you can say 1, 2, 10. So let's try that one out. Okay. It works the other way too. So I could actually have U as 10 minus 2, 1. So then I'm going to go down, because that might be useful for whatever it is that I'm doing. So I could count up or count down. What do you think will happen if I do this? Error, it's actually just going to say, well, there's nobody who satisfies that, so it's just going to give you an empty array. Okay? It's not going to give an error, so it's not going to yell at you. It's not going to give any. It's just the result is an empty matrix, and that's something that MATLAB can work with. So if you type this into your program, simply because you had a typo, okay, it's not going to yell at you. It's going to create an empty matrix, and somewhere down in the calculation, 7 lines below, it's gonna bomb. Okay? You're gonna use it as an array that has 10 values and it actually has none. And somewhere in there you're gonna create an error. So those are the errors that we want to refer to as avoidable errors. You could have avoided that, but you still have to actually go and locate it if you do it. Because you didn't do it intentionally. Okay? That's part of the mistake. So you have to be on the lookout for things that cannot properly execute. Again, sometimes MATLAB returns an error and doesn't let you proceed, which is great because then you can fix it right at the spot where it's the problem. But if it doesn't, you kind of have to track down the mistakes. And that's essentially the problem in programming and the most tedious part of weeding out issues. Okay? So if I wanted to grab an individual, so this column notation is really useful. So I had my matrix A. I'm not going to retype a different one, as suggested by my slides. So if I wanted to grab an entire row or entire column, okay, the way I would do, so I know that A2, 3 just returns a precise element of this matrix. But let's say that I wanted an entire third column. Everybody from 3, I'm just going to put a little column there. And that tells MATLAB to say take everybody that has column 3 in their address. And that's my entire column. I can be actually more specific and say 1 through 3. I know that there's 3 of them. I could say 1 to 2. Okay. I could actually say, well, skip every other. Go in between 1 and 3 and skip every other. Not much is left because this is a small matrix. So this is first and third. To remind you, A is this. So first and third is 7 and 4. Give it a try. I tend to go fast, so when I spit out 4 commands and just type them in quickly, somebody show me. Slow down, slow down. So the point is, just like I use column notation to create vectors, right? And I can create vector between 1 and 10 with spacing 2 or 3 or whatever it is. I can use that same notation to refer to locations in my matrix. Okay. And so those locations can be whatever it is that I come up with. Here I'm saying go between elements 1 and 3 and skip every second, right? And this is something, this in itself, the result of this is an array. Okay, that array is 1, 3. Okay. So what MATLAB will do is say, okay, take 1, 3, and 3, 3. And that's what it gives me back. So that's a super flexible way. And I can tell you right now, all of the other programming languages, okay, can't do this. They're not as convenient. You have to be a little more straightforward in how you tell them to grab information. So this kind of flexibility is very intuitive. It's kind of unique for now to MATLAB and the sort of similar programming. There's a new one called Julia, I believe. Mathematica has the similarities as well. But the old-fashioned programming languages don't have this type of flexibility. Okay. So I have already, like all of the matrix operations, I kind of folded them into this review. You can multiply your matrix by a scalar. You can just say 2 times A, and it's going to work as scalar matrix multiplication. You can actually type in A times B, and note that the times symbol is the same in both cases. So when I'm typing in, so there's a very subtle difference, which again is quite specific to MATLAB. 2 times A, okay? and A times B are two very different things. First one is multiplication by scalar, which takes this scalar and multiplies every element. Okay? And the second one is matrix multiplication, which has its very specific rules. And times is a command which will say, aha, I'm going to first recognize who is who here, who am I working with. If I'm working with a scalar and matrix, I'm going to do scalar matrix multiplication. If I'm working with two matrices, I'm going to do matrix matrix. So there's sort of a split in the code, and we will learn how to program those that based on whatever it is that you recognize, executes one thing or the other. And it's super useful because it just allows you to operate the way you would in math and not just in programming. Okay, you can do dot product too. So if I had U and V, I'm actually going to be lazy and I'm going to copy them from my slides, but you should type them in. So my U is a row vector, V is a column vector. You can do U times V because this is 1 by 4, this is 4 by 1 matrix. So it's actually essentially going to do matrix matrix multiplication, which in this case is actually a dot product. There's also a command .uv. It's going to do the same thing. I keep forgetting your name. Okay, one of these days I'm going to learn, but give me 2 weeks, by the way, to remember your names, and I should get there. So if I had U prime, which is basically my transposed U, okay, so if I had two column vectors, would I be able to do matrix multiplication with them? No. So that's one thing, the difference between these two commands. So if I had U prime, which is basically my transpose of U, U prime and V both have 4 by 1 dimension, so I can't do this. Whoa! Okay. Have a sound effect telling me I cannot do it. Okay. Because my inner matrix dimensions must agree, and that's because this command is interpreting these as matrices. Okay. Dot product would still work, because it would just take that. It will take it, oh, well, they have the same number of elements, I can do this. Okay. So that's that same subtle difference that you will have quite a bit of on your homework. And the subtle differences here is also pointing to the fact that you kind of always have to know what it is that your program expects you to do. And for that, help is useful. So you could, for any command in MATLAB, say help and name of the command. And you might get more than you're willing to read, but it's all going to be there. So dot is vector dot product. C of dot AB returns the scalar product of the vectors A and B. Okay? And they have to be of the same length. So it's telling you how do you use. Again, any command you can use help on. This is within MATLAB, so that this travels with MATLAB whether you're online or not. As I pointed out, Googling works really well because MATLAB is a company and they're invested in learning quite a bit. They're selling a product that is used for education a lot. So they're pretty good about producing documentation that is searchable. But again, that depends, of course, on the company. So essentially, you will go and you can find those things online as well. So whatever you prefer. Okay, so help, again, is built in, so you can do help on any command that you forgot how to use. There's also a command that gives you ones and zeros. There's actually a whole array here. Okay, so I'm gonna give you all 2 minutes and pick one that I didn't mention here. Do help on it and try it. So one of these built-in functions, diag, I, ones, rand, length, lin space, log space, zeros, size. We worked with size, log space, lin space, rand, and I. Try one other, do help on it, figure out how to use it. I do expect you to kind of have operating knowledge of all of these. They're simply very useful. Which one did he pick? Zeros. What does it do?
So it just creates a matrix of zeros.
Full of zeros. That can be useful sometimes. Huh? So how would I create a matrix that is 5 by 6 and full of zeros?
So you do 0, parentheses, 5, 6.
5, 6. That is it. Okay. Ones works the same way. Gives me ones. How would I create a matrix full of threes? No. Do something for these ones. 3 times, yeah. So you can scale this any way you want. Okay. I could work with diagonal, so that diag is diagonal. That's where are the ones here? So it doesn't like that this is not a square matrix apparent. Oh, never mind. I should now use help. So diag actually is going to do diagonal matrix of a vector of values that I give it. And I interpret it as 5 as a vector of values. So it's just going to place 2, 3, 4 on a diagonal. And one final exercise using the sum of the functions that we learned here. What is the angle between these two vectors u and v? So u is given, v is given, type that in. There's a number of ways you can do this, by the way, and that's also, as long as you know what the formula is for the angle between two vectors, you can typically go at least 3 different ways to find that. I'm pointing out you can use dot product. You need a reminder. U dot v divided by norm of u, 2 norm of u, and L2 norm of v.
For L2 norm, do we just put norm or do we have to put?
Try. Do help norm. So that's a great way. So the moment you ask yourself, hey, is there a function named norm? Try. Okay? Help norm, or go to Google, say, how do I do norm? Or you have a formula, you can compute it. Okay? So you can go and simply compute. Square root, by the way, is SQRT, if that's the route you want to go. Or check out if norm exists. So the questions that you would ask me, okay, sometimes when I'm not around, type them in Google. Give it a try. MATLAB is so used that probably answers somewhere exist, or you could of course pick up a textbook and take a look as well. Or if you're not online, well, you know the formula, you can implement it. Oh, sorry, this was cosine. Nobody said anything. So just before I go, so let's just do this. So cosine theta, whoa, hi. U is -2, 1, 3. V is 1, 2, 3. Okay. Cosine theta is U dot of U V divided by norm of U times norm of V. Oops. Okay. Now norm, if you just put norm of U, it's actually 2 norm by default. So if you don't specify, it's thinking Euclidean. Otherwise, you say 1 norm, it's going to give you 1 norm, or infinity, it's going to give you infinity norm. Okay?
We're supposed to calculate the angle, right?
Yes, so I calculated cosine theta. Okay? So now, if I say A cosine, and you want D because you want that in degrees, it's nearly 50 degrees, and this is otherwise in radians. Okay? Clear? So there is A cosine. So most of the mathematical formulas that you would type in into calculator, they do exist. SQRT is different from the calculator, right? But all the others, cosine, sine, and so forth, they're similar as what you would have on your calculator. Okay?
Do we usually use radians in this class, or?
Up to you as long as you know what you're using. Okay? All right. Thank you. See you on Wednesday. And